Hey, welcome back everybody. Today's objectives are to identify areas of probability in genetics and to learn how to solve a Punnett square. In genetics, we have a lot of things that have to do with probability. Probability is the likelihood that an event will occur. We could put this into an equation. Probability equals the event or the number of events over the number of outcomes. So when we look at this simple example of flipping a coin, what is the probability that the coin will be heads up? All right, so probability equals the number of events, so we're flipping it one time, over the number of outcomes. There are two possible outcomes, heads or tails. So in this case, the probability of flipping a coin that will land heads up will be 1 over 2 or 50%. So how does probability fit into genetics? I'll give you a personal experience or a personal situation. My mom and dad had 3 boys. So that's like if we say that boys are heads and girls are tails. I want to know, what is the probability that when flipping a coin, the coin will be heads 3 flips in a row? Or what is the probability that my mother would have 3 boys without having a single girl? The way that we would do this is we would look at each life event. What I mean by that, my older brother, he had a 50% chance of being a boy or 50% chance of being a girl, or 1/2. So it was one event, one birth, 2 different outcomes. I was the same, and so was my little brother. We had a 50% chance of being a boy or a girl. To have 3 boys in a row is a lot harder, mathematically or probability-wise. So it's going to be less than, logically, it's going to be less than a 50% chance because we have 3 separate events going on. The way that we figure out the probability of 3 different events is we multiply the probabilities of each together. So 50% that my older brother would be a boy, 50% that I would be a boy, 50% my little brother would be a boy. When you multiply, you would multiply the denominators. 2 times 2 equals 4, times 2 equals 8, and the numerator is 1 because 1 times 1 times 1 is 1. So the probability would be 1/8. So let's take a look at a video that's going to help us review a little bit about Mendel and also take us further in today's lesson on Punnett squares.
These days, scientists know how you inherit characteristics from your parents. They're able to calculate probabilities of having a specific trait or getting a genetic disease according to the information they have from the parents and the family history. But how is this possible? To understand how traits pass from one living being to its descendants, we need to go back in time to the 19th century and a man named Gregor Mendel. Mendel was an Austrian monk and biologist who loved to work with plants. By breeding the pea plants he was growing in the monastery's garden, he discovered the principles that rule heredity. In one of the most classic examples, Mendel combined a purebred yellow-seeded plant with a purebred green-seeded plant, and he got only yellow seeds. He called the yellow color trait the dominant one, because it was expressed in all the new seeds. Then he let the new yellow-seeded hybrid plants self-fertilize, and in this second generation he got both yellow and green seeds, which meant that the green trait had been hidden by the dominant yellow. He called this hidden trait the recessive trait. From those results, Mendel inferred that each trait depends on a pair of factors, one of them coming from the mother and the other from the father. Now we know that these factors are called alleles and represent the different variations of a gene. Depending on which type of allele Mendel found in each seed, we can have what we call a homozygous pea, where both alleles are identical, and what we call a heterozygous pea, when the 2 alleles are different. This combination of alleles is known as genotype, and its result, being yellow or green, is called phenotype. To clearly visualize how alleles are distributed amongst descendants, we can use a diagram called the Punnett square. You just place the different alleles on both axes, and then you figure out the possible combinations. Let's look at Mendel's peas, for example. Let's write the dominant yellow allele as an uppercase Y, and the recessive green allele as a lowercase y. The uppercase y always overpowers its lowercase friend, so the only time you get green babies is if you have 2 lowercase y's. In Mendel's first generation, the yellow homozygous pea mom will give each pea kid a yellow dominant allele, and the green homozygous P dad will give a green recessive allele. So all the P kids will be yellow heterozygous. Then, in the second generation, where the two heterozygous kids marry, their babies could have any of the three possible genotypes, showing the two possible phenotypes in a 3-to-1 proportion. But even peas have a lot of characteristics. For example, besides being yellow or green, peas may be round or wrinkled. So we could have all these possible combinations: round yellow peas, round green peas, wrinkled yellow peas, and wrinkled green peas. To calculate the proportions for each genotype and phenotype, we can use a Punnett square too. Of course, this will make it a little more complex. And lots of things are more complicated than peas, like, say, people. These days, scientists know a lot more about genetics and heredity, and there are many other ways in which some characteristics are inherited, but it all started with Mendel and his peas.
Alright, so we just looked at a video that helped us take Mendel and genetics to the next step. They talked a little bit about Punnett squares. I just want you to be familiar with the term monohybrid test cross. That's a Punnett square that is testing for one gene, alright, and it usually has two alleles. Punnett squares are used to predict the probability or the different genetic variations that will result from a cross. And last lesson we talked about homozygous and heterozygous conditions. So if we take a look at this Punnett square, we're looking at the gene for height. And there's two different alleles. We have the big T, which is tall, the little t for short. And we have two hybrids that are being crossed here. They both have a big T and a small t parent. So when we complete the Punnett square, or the monohybrid test cross, you'll bring the allele down, and this allele over for big T, big T. Then you'll have a hybrid, and a homozygous recessive, two little t's. You just bring the letter across and bring the letter down to get that. Now, as you can see, there are percentages next to the outcomes, or next to the alleles here. And that is what percent is going to have big T, big T. So basically, what percent is going to have the genetic makeup of big T, big T? What percent is going to have the genetic makeup of big T, little t? If we would look, there's 25% there, 25% there, so that would be 50% would be total hybrids. 25 homozygous dominant, 25 homozygous recessive. So how do geneticists, or people like Gregor Mendel, use Punnett squares to gather data? From a Punnett square, we can look at two different types of data: the ratios of the phenotypes that are present, the ratios of the genotypes that are present. A phenotype are physical characteristics that we can see. If we take a look at this Punnett square, we can see that we have a tall plant here, here, and here. We can see that this is a short plant. So an example of a piece of data that we can conclude based on this Punnett square is that 1/4 of the plants are short. This is the only short plant, or 3/4 are tall. The genotype, or genotypic ratio, is the genetic makeup of each plant, and that consists of both of the alleles. We don't always know both of the alleles just by looking at them. However, we can kind of figure them out by doing a Punnett square if we knew both of the genotypes of the parentals. So big T occurs in a ratio of 1/4 of the time, because it's the only outcome that is likely based on two hybrid parents. Little t only occurs 1/4 of the time, and the hybrid situation happens 2/4 or 50% of the time. So these are just two bits of data that we could collect by filling out a Punnett square. It's just showing us the likelihood of an outcome, or a probability of an outcome that could happen based on a set of parents that are crossed. Today's objectives were to identify areas of probability in genetics. We just went over a couple today, Like, what's the likelihood that you will have 3 males before you have a female offspring? Uh, we'll look at other ones in the future, such as what's the likelihood of having a child with brown eyes over a child with blue eyes, or uh, having a tall child versus a short child, and what goes into that. We also took a look at how to solve a Punnett square. I know most of you knew this from middle school, but if not, hopefully you got a look at or a refresher at how to do those. Please make sure that you know the difference between phenotype and genotype. We will definitely go over this next class, and we will have a lot of practice with it, but it's very important that you know the difference between the two. If you have any questions, please bring them to class.